right, we're on the air. Keep it clean. Let's see. Chain rule. Chain rule. Wait, I lost my topic. Hello. Here's our topic, chain rule. Who asked for you? All right, it's Friday the 25th already. Holy cow. You mean it's almost October? Oh yeah, and you get Thursday off. You get, what is this racket? You get Monday off, you get Thursday off? Well, Thursday, I didn't schedule anything because ninth period got screwed. You know about Thursday, right? Next week? You got senior pictures after, ninth period. So it ruins ninth period. Where do you have ninth period? Well, it's gone. You know All right, so, but you guys are here first period on Thursday, so I guess we'll go over questions you might have on homework or something like that. So instead of having the review on Thursday, we're having it on Wednesday. That's the pretest on Wednesday next week. So we only have today and Tuesday to finish this topic. Here we go. Oh, God. Okay. So chain rule. What if f of x, h of x, let's say, h of x is f of g, a composition of two functions. You have an outer function, you have an inner function. What's h prime? Ethan knows everything. Wait, Victor knows some. Wait, Victor knows stuff. What? Wait, speak up, man. No, there's not a product. Oh, jeez, I thought he knew something. Oh, it was dangerous. Okay, Matt. Wait, Matt. Declaim the chain rule.
I think it's n, u, n minus 1.
Well, that's only if you have a power. That's only if you have a power function. F could be any function. The outer function does not have to be the power function. And we go back to Ethan. Oh, no, we go back to Patrick.
D prime times D prime x times x. No.
Well, you're closer, I guess. Not quite. I don't think so. Ethan.
We do f prime of g of x times g prime of x.
Where did that come from? Amazing. Yes. Are you reading ahead? Or you know this stuff?
Yes.
You're reading ahead? Top secret stuff you're not supposed to read ahead? No, you can read ahead. That's a good thing. Okay. So yeah, so if you're taking the derivative of a composition of two functions, you take the derivative of the outside function composed of the inside and times the derivative of the inside.
Oh, I thought g and x are two separate variables.
No.
That's wrong.
Okay. What if r of t, remember parametrics? What if r of t, your position vector or your radius vector, is x of t, y of t? What's the velocity vector look like? X prime, y prime, right? I'm going to write it this way. dx dt, dy dt. And you can calculate the acceleration vector and jerk vector and all kinds of fun stuff. But what if I want dy dx? If you have a parametric trajectory, parametrically defined trajectory, and the velocity vector is defined, can't you get dy dx from this? Anyone see it? Anyone ever see that before? Right, dy dt divided by dx dt. Why?
Because then when you divide the
Right, when you divide by a fraction, you multiply by the reciprocal. dy dt times dx dt. No, sorry, the reciprocal. dt dx. Alright, and so the dt's cancel and you get dy dx, right? That's another statement of the chain rule if you have parametric function or parametric relation, okay? So there's two statements of the chain rule. This is the one you usually see is this one, right? But this comes up in parametrics. Okay? So, let's see. What about this? May I move on? Mother, may I? No? Okay, Mother Patrick. Right? Go. Go, go, go. So, what if y is 9x squared plus 6x plus 1? What's y prime? 18x plus 6. But that wasn't the question I was going to ask. What if y is 3x plus 1 squared? Now, wait a minute. Do you see the relationship? What is it? It's the same thing. If you follow this out, you get this, right? Okay. So according to the chain rule, how do you do the derivative of this composition of two functions? The inner function is linear, the outer function is quadratic. So what do? 2u to the 1, you don't have to write it, but there it is, times, don't forget, du, right. That's it. Done. That's exactly what it's said to do in this rule over here. And that's the next question. Is that the same thing as 18x plus 6? Well, 2 times 3 is 6, and distribute the 6, you get 18x plus 6. Amazing. Phenomenal. No? You don't? Huh? Oh, I was bad. Sorry. Prime. Yeah, so maybe this is confusing. Okay? Yeah, that's a chain rule. Nothing more to it than that. So you can do much more complicated derivatives if you have compositions of functions you already know how to differentiate. You have to differentiate the outer function, you have to be able to differentiate the inner function. Okay, what if I said, let's see, y equals, what do I want? 1 plus 2x, I don't know, cubed. What's y prime? 3 times times 2. Okay. Times the derivative inside is just 2. Okay. What if it's y equals x squared plus 1 to the 5th? I can't write it. Plus 1 to the 5th. Y prime would be 5 times x squared plus 1 to the 4th times 2x. All right, let's consult Hal and see if Hal agrees with that. I'll do right there. All right, how do I do derivatives down here symbolically?
Because at 3 and then 3.
Yeah, or second 8, same thing. All right, now the first one was, what was it? 1 plus 2x to the 3rd? Okay. So quantity, 1 plus 2x to the 3rd, close the parentheses, to the 3rd, with respect to x, is that what we said?
No.
Yes, it is.
Oh, no.
Oh, you're doing the 18x plus 1. Yeah, I'll get to that. All right, and then let's do second 8 of this guy. What was this guy? Right, this thing. All right, so open parentheses, x squared plus 1, close parentheses, to the 5, comma x, because you can differentiate with respect to any variable if there's more than one variable in your expression. That's next year, calc 3. And, 10x, is that what we got?
Yeah.
That's what we got. Okay, what about the first one we did? Second 8 of 9x squared plus 6x plus 1, and that comma x. 18x plus 6, right. Or second 8 of, what was it, 3x plus 1 squared? Quantity? Quantity, 3x plus 1 squared with respect to x. That's the dx, right? That's why, that's what we're doing, dy dx is really what that is. And, well, that's basically the same thing. Right? If you don't like that, okay, F2, expand stuff.
Oh, I didn't know how to do that.
Okay? Yeah, you got to get used to your computer algebra system that's built into the TI-89. It used to be a program called PC Derive. It's built into your calculator. Alrighty, so, go ahead. So, take a look at some EP-style free response questions. You're so good at this stuff, it's time. We'll start with 88 AB1. Yes!
I thought it was hard.
This was hard, but now it's not? I was lost and now I'm found. Yes. AB1, let's start easy. You don't want to start with BC7, do you? We'll get there. Let's start with an AB1. This is 88 AB1. All right, we're going to take a look. We're going to take our time with this packet today and Monday, all right? So bring it Monday. Here we go. Which is Tuesday, right? Don't forget about Yom Kippur's. So let's move on. Wait, hang on. Am I offending anyone? Ethan? Okay. All right. I'm sorry, I had a crazy professor. He used to always call that. Yeah. Sorry, I shouldn't do that. All right, anyhow. It is 88 AB1. Pretend it's 1988, and this is your AP. Oh, boy. So, let f be the function given by f of x is the square root of x to the fourth minus 16x squared. Yeah, my printer went weird yesterday. Well, you know what it is? Word 2007 is ruining my Word 97 files when I print them. So, and I got to figure out how to fix that. But anyway. So, first question. What's the domain of the function? Well, we haven't talked about domain and range too much. What's the domain of any function? Of any function y equals f of x. All the x's that are legal to be plugged in other words, where the function's not undefined, right? And what's the range? All the y values you get when you plug in all those x values that are legal, right? Okay, so how do you find out what are legal x values here? Right, the argument of the radical better be greater than or equal to 0. Okay, so how about, first of all, we find the zeros. This is going to be like a sign line test. Let's find the zeros, and let's find out where then it's positive, and that's the domain. Right? Where it's 0 or positive, we can square root. Otherwise, we're not allowed. Remember, this is a course in the calculus of y equals f of x, real valued functions of a single real variable. We're plugging in real numbers, we're getting out real numbers. So we're not dealing with square roots of negative numbers here, okay? We're not allowing that in our domain. Wait until you take complex analysis, Calc 10. Yes. Yes. Well, yeah, we're reviewing Calc 1, so technically we're in Calc 1. Oh, there's a Calc everything. It goes on forever. You know how this is called AB Calc, right? A really means pre-calc, and B means the beginnings of calc. And then we're going to do BC Calc, right? There's a letter for every calc. When they run out of calculus, they make up more. When do you run out of calculus? When you can't solve a problem in the real world with any other tools. So you come up with something new. This happens all the time. The last time they ran out of calculus, Einstein was banging his head against the theory of relativity. So he made up a new kind of derivative. And they were up to Calc S, so he had to make up something he called it Calc T. I kid you not. That's why they call his derivative the tensor. Tensor calculus is Calc T. And there's been more calculus since then. It goes on and on and on and on. And whenever you hit a problem you can't solve, invent new math. Because math is the language of the natural world, and if it's in the nature, you can solve it. There's got to be some kind of way of describing it mathematically. It always has been, it always will be. Okay? So that's the idea. So, when is the So when is this 0? Let's start there. What's your favorite F word? Factor. Yeah, watch how many letters you use. So, factor out what? X squared. What's left? X squared minus 16. Okay. And that can be factored further, no? Okay, so x squared times what? Sounds good. So you got the zeros. X can be 0, or X can be
-4.
-4. That's already got an X there. What are you doing? -4. Or X is +4. So let's do a sign line, like we're doing critical points of a derivative, finding mins and maxes and stuff. I'm just finding positives and negatives, right? So the domain is this. The domain of this function is all real numbers. I'm looking at this function, right? The argument inside the radical. I'm just looking at this for now. So it's all real numbers, but it has a 0 at 0, and at -4, and at +4. My question is, where is it not only 0, which is allowed, because then you can square root it, right? But where is it also positive? So remember, it can change sign, because it's a continuous function, isn't it? Right? This is the intermediate value theorem. It can only change sign if it's a continuous function where it hits a 0. Right? So it could be positive here, and then it could be negative there, but if it's positive here, it's positive all the way through here. It can't change until you hit a 0, right? That's the intermediate value theorem. If it's negative here, positive there, you had a 0, right? That's the only way you're going to get a 0. All right, let's start here. What's a nice number to plug in? 1. Okay, so 1 squared is positive. 1 plus 4 is positive. 1 minus 4 is negative. So that product's going to be negative. Positive times negative, right? All right, let's pick a number in here. -1. Okay, -1 squared is positive. -1 plus 4 is positive. -1 minus 4 is negative. So positive times negative again. So the domain doesn't include -4 to 0, does it? The domain doesn't include 0 to 4, does it? Because we want to square root it, we're not square rooting negatives. How about something bigger than 4? 5, okay. 5 squared is positive. 5 plus 4 is positive. 5 minus 4 is positive times positive. Positive. All right, these are X values, right? And what about if you plug in a -5? -5 squared is positive. -5 minus plus 4 is negative, but -5 minus 4 is negative, so positive times negative, positive. So state the domain. It's all X values on what interval? Member of what set? What's included? What can you square root? Can't square root the negatives, right? So negative infinity to -4. What else? 0 is allowed, right? You put 0 in there. What else? 4 to positive infinity. Okay. Now, I can't ever include infinity, positive or negative, because it's not a number. That's got to be open. Is this open or closed here? Closed, because -4 gives you 0. You can square root 0. That's okay. And what about this guy? 4, is that included or not? Okay, so that's just what's called a semi-open interval. That's a semi-closed interval. And I'm going to unite it with the single point at 0. All right, so it's all these numbers, union 0, union all these numbers. That's the domain. Okay, this is pre-calc stuff, but you got to know this stuff, especially if you need to graph something by hand. There's sections in the tests, AP tests, where you don't have the calculator, you might have to graph by hand. All right. Okay, so part A, done? Easy? Yes, no, maybe so? Okay. All right, part B. That was part A. I hate words. I know, shut up.
You have to write it like that, that's the only way.
Well, give me another way to write it. That will be given credit on the AP. Yeah, that's fine. Yep. You described the same
That thing right there, is that it? Is that
Oh, such that. Oh, you want to do it like that? Okay. Yeah. Okay. How about this? Let's see. How am I going to do this? The range of, the domain of F equals the set of all X such that X is less than or equal to 4, or X is equal to 0, or X is greater than or equal to 4. Is that what you like? Oh, -4. Negative. Is that what you want? That'll do. That works. That is the such that symbol. I think they'll recognize that. They're not going to be pesky about symbols as long as they can understand. I think they'll understand that. If they don't, if you write something that's unintelligible, well, sorry, you're not going to get points. But I think what you wrote would get credit. Okay, he likes to see put a vertical line here. Right? Now on the calculator they have that, right? Isn't that the width key on the calculator?
What?
The width key.
What's that?
What does that mean? Well, that means I could take this derivative, let's say, clear this. Let's say I could take this derivative here, and I could find it algebraically, or I can evaluate it with x equals 1. Okay, that's the width key. That's a such that key. It's what it is. Such that x equals 1. Find the derivative of this thing such that x equals 1. See, you learn something new every day. At least in here you do. All right, so next, part B. Describe the symmetry. Now remember, f of x is x to the fourth minus 16x squared when it's square rooted. And remember the symmetry we've talked about? We've talked about odd and even symmetry, right? Even symmetry is symmetrical about the y-axis. Odd symmetry is symmetrical about the origin. Remember the definition is if f of negative x is the same thing as f of x, that's like a parabola, right? If f of negative 2 is 4 and f of positive 2 is 4, it's going to have that y-axis symmetry. If f of negative x turns into the opposite of f of x, that's going to be origin symmetry, like y equals x cubed. So if f of negative 1 is negative 2, and f of positive 1 is positive 2, that's going to be symmetric about the origin, reflection through the origin, right? Well, you got to prove it. You got to plug in negative x and see if it's the same or if it's opposite.
What is your picture of a graph?
That works too, but you got to write stuff. You have to draw a complete graph. You have to label it painstakingly, x-axis, y-axis, function, zeros, y-intercepts, the whole schmeal, and then you got to write some verbiage. Look at the graph, it's symmetrical about the y-axis because blah, 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 blah. Right? It's a lot more writing involved. I would rather do this algebraically. What's f of negative x? It's the square root of, what do you do? What does that mean to do? Plug in negative x, that's all. And work it out. And either you get this, or you get this, or you don't have symmetry. It doesn't work. Okay, so what's negative x to the fourth? X, really? X to the fourth, okay. And what's negative x squared? X squared. So guess what you ended up with? What you started with. So, y-axis symmetry. Okay? Now, here comes the chain rule, part C. What's the derivative of f? Are you ready? Okay, y-axis symmetry. If it's a function, it can have y-axis symmetry or origin symmetry. It can't have x-axis symmetry. Why? If it's a function, it can't have x-axis symmetry. Why? Because for every x value, then you have two y values. If it has x-axis symmetry, right, like a parabola that opens to the right or to the left, that's not a function. They're talking about a function here, so don't worry about x-axis symmetry. Okay, let's do derivatives. If f of x is, what the heck was it, x to the fourth minus 16x squared square rooted, how do you find y, f prime or y prime, whatever? 1/2 power, okay, good. Let's use our chain rule. Oh, it's yours now? Okay. All right, I didn't know you owned it. You got a copyright? We have a copyright on this? Okay, whatever. Newton, maybe.
But he's dead.
But he's dead. Yeah. Copyright law only covers you, 40 years after death, so it's up. Is it 100 years? Well, we're still up. 300 years, yeah. So, I guess it's in the public domain. We can use it. Let's do it. What goes here? 1/2 times x to the fourth minus 16x squared to the negative 1/2 times. Oh, you're so good at this, it's scary. And that's fine, you're done, but let me clean this up a little bit. That's a numerator, right? You don't have to, but usually if I start with a radical, I have to end with a radical. So I'm going to write it in radical form, and I don't like negative exponents if I can avoid them. So, this is a numerator, this is not. This is a numerator, this is not. So you get don't you? Oh, I lied.
But you could leave it like the top, right?
Yeah, you can leave the 2 on the bottom, yeah. Yeah. Well, when you, on my tests, I like to see answers in simplest form, but on the AP, they don't expect you to put everything in simplest form under time constraints. So you could leave it unreduced, I guess. All right. Now, what's the slope of the normal line at x equals 5? Now, they didn't even ask for the line, they just want the slope.
Oh, man.
So what do? Either.
Do the hydrate, derivative for x equals 5, and take the negative.
There you go, sounds good. So let's do that. This is part D now. Okay, so this is f prime. I want f prime at 5. Now think about this, it's 1988. We had bear skins and stone knives. Okay, we did not have a calculator, much less a graphing calculator, okay? So this is something you should expect to see in the non-calculator section of your AP. Can you do this by hand?
Yeah.
This is not terrible, is it? It's just arithmetic. Arithmetic is your friend. It's okay. 2 times 5 cubed minus 16 times 5 over 5 to the 4th minus 16 5 squared. Square rooted. Oh, God. I don't know. Better watch out. It's arithmetic. All right, so 5 cubed is 125 times 2, 250. 16 times 5 is 80. All right, let's do stuff down here. Now 5 cubed was 125, so 5 to the 4th? 625, is that right? No?
Oh, 600.
Really? Well, maybe in base 6, but not in base 10. So what's 5, what? Is it 635? Let's see. 5 times 5 is 25. And 25 times 5 is 125. But 125 times 5, children, is 25 carry the 2, 10 and 2 is 12 carry the 1, and 625. Yes. Look, you're not helpless. You can do it this way if you have to. God darn it. What's 5 squared? 25 times 16. 400. Where were you yesterday? We did the exact same calculation. Right? 25 is a quarter of 100. Right? 100 times 16 is 1600. But I want a quarter of that. 400. Oh, this is tough. Okay, so 250 minus 80? 170? Okay. And 225 minus 400? 225, but that's a perfect square of 15. And I guess that's good enough. But you can reduce that, right? Can't you? What goes in the... Right? It goes by 5, right? 34 fifths. Okay, what if you want a decimal? Damn it, it's 3. Why did you do that to me? No, the tablet did it, so don't reduce stuff. All right, so what if you wanted a, what should we call it, a mixed number? 11 and 1/3. What if you wanted a decimal rounded up to 3 places?
11.33.
And the exact answer is 3 repeating, right? Okay. Oh boy, you're so good at arithmetic. It's scary. Yeah, this question had a lot of pre-calc and arithmetic in it, didn't it? But it happens. That's why it's called A-B calc. A is the pre-calc stuff. Yeah. Okay? Oh, we got carried away with the arithmetic and forgot the calculus. Oh, geez. So, the slope, therefore, slope of normal is negative 3 over 34. Thank you. Yeah, you got to write that. You got to label the answer somewhere. You can't just write negative 3 over 34 someplace and expect anybody to know what you're doing.
Well, you're doing the question after.
I know, but you got to speak in coherent sentences and equations. Sorry. We're not going to be incoherent on the AP exam. Alrighty, 88 AB2, you ready? A particle moves along the x-axis so that its velocity at any time t greater than or equal to 0 is given by v of t is 1 minus sine 2 pi t. Alright, so it's moving along the x-axis, so this is parametric. If it's moving along the x-axis, it's a horizontal trajectory, y is 0. Right? And that's x prime, isn't it? That v of t, that's really x prime or dx dt, isn't it? Okay. Find the acceleration a of t at any time t. Okay. Alright, so they're going straight into the calculus here. This is cutthroat. I don't know. Well, because it's AB2, it's sort of tough. That's a B, okay? Ding, ding, ding. Okay, so V of t is given. It's 1 minus sine of 2 pi times t. So what's the acceleration of dv dt? The derivative of a constant? 0. Derivative of the cosine of u? That's I said it wrong. Derivative of the sine of u? Cosine of u du. And does it change the SIGN of the SINE? No, so it's negative. What should I write? Negative cosine of 2 pi t times 2 pi. How about we just put it in front? Is that okay? Okay. Alright, B. Find all values of t between 0 and 2 when this thing is at rest. When is this thing at rest? When the velocity is 0. So let's solve. 1 minus sine of 2 pi t is 0 when? Now this is pre-cal now. This is just some algebra. Add the 1. No, that would give you 2 here. Subtract the sine. That would give you 2 sines. Subtract the 1. That sounds good. Okay. Or add the sine if you like. I'm going to add the sine. What the heck? I'm going to be a rebel without a cause. I don't know. It's so complicated. So the sine of 2 pi t is 1. Now, what angle do you know, what radian angle do you know whose sine is 1? Well, yeah, but give me radians, though, because we're using derivatives and stuff. Pi over 2. So 2 pi t has to be pi over 2. The sine of what is 1? The sine of pi over 2. Okay? Now, remember they said the domain of this problem is t is 0, between 0 and 2, right? Inclusive?
T is 1 over 4, right?
Yeah, but wait, is that the only time you get the sine equal to 1? No. At 270 degrees, the sine is negative 1. Right? Or I should say at pi over 2, 2 pi over 2, 3 pi over 2. Then at 4 pi over 2, 5 pi over 2, it's 1 again. There's a whole bunch of possibilities.
Oh, like that, 360.
Right? Go 360 around, 360 around. In other words, I'm adding 4 pi over 2 every time. When do I stop?
How fast? At 2. On T.
As long as the answer is less than 2, I'm good, right? Okay, so let's see if that's enough. I don't know. So t is 2 pi over 2 divided by 2 pi. Well, what does that become? Wait. Pi over 2 divided by 2 pi. The pi's cancel and you get a quarter. Because remember, you know how to do this. Pi over 2 divided by 2 pi means multiply by 1 over 2 pi. Right? So the pi's cancel and you get a quarter. Right? Okay, so you get a quarter. That's in this range? Or this domain, I guess? Okay, so that's a quarter. Now let's see if we need this one. We don't even need this one. I don't know. If I divide by pi, it goes away. If I divide by 2, I get 5 quarters. Is that in here? 1.25. If I divide by pi, it goes away. If I divide by 2, I get 9 quarters. That's 2.25, so no good, right? It's bigger than 2, so I'm done. So the particle is at rest when t is 1 quarter or 1 quarter or 5 quarters seconds or something. They didn't give you units, so don't worry about the units. Find the position x of the particle at any time t when x is equal to 0. Well, we have to integrate for that, so skip it. We're not doing that today. Okay? I don't know. No, skip it. No, I can't do it. That's too much for today because that's a chain rule backwards. You know U sub? You ever do U sub? That's a chain rule backwards. We just introduced a chain rule for the first time ever. I'm not doing chain rule backwards yet. Don't get crazy. All right, so let's go to 91AB3. Next one. We'll come back to stuff like C. Don't worry. All right, 91AB3. Give me a pen. Give me a pen. 9, it was too, AB1 was too easy. Okay, so let f be a function defined by f of x equals 1 plus tan x to the 3/2. And the domain is restricted to negative pi over 4 to pi over 4, an open interval, pi over 2, non-inclusive. Okay. Write the equation for the line of the tangent, or the line tangent of the graph of f at points where x equals 0. Well, to get the tangent line, we also need not just f, but f prime. And f prime, according to the chain rule, is 3/2 times 1 plus tan x to the 1/2 times secant squared. You're scaring me. Are you going to get 100 in the next test? I hope so. And they want to know f prime at 0, right? So what's f prime of 0? It's going to be 3/2 times 1 plus tan 0 to the 1/2 times the secant squared of 0, right? So what's the tangent of 0? Right? That's the sine of 0 over the cosine of 0. That's 0 over 1. So 1 plus 0 is 0, and the square root, 1 plus 0 is 1, and the square root of 1? 1 times 3/2? 3/2. And what's the secant of 0? 1, because that's 1 over cosine 0. Cosine of 0 is 1. And you square it, it's still 1, so you get 3/2. Wow, you can do this stuff. Okay, using the equation found, well, we didn't write the equation yet. So we also need f of 0, don't we? We didn't get f of 0. Well, we did, because if we plug in 0, what's tan 0? Tan 0? 0 plus 1? 1 to the 3/2? 1. So we have f of 0, right? F of 0 is 1. So we need both to do the point sub form. Y minus 1 equals 3/2 times x minus 0. And if you like y equals mx plus b form, simplify and add. Okay, they didn't say write it in this form, so you don't have to. Unless you want to graph it, it'll be easier to graph this, especially in the calculator. All right, you know what? I'm going to save the rest for Monday, which is Tuesday. Have a nice day.